Hello guys, now to solve first order differential equations, one of the way is how to solve an exact differential equation. Now if we have an equation of this form, m dx plus n dy is equal to 0, it is said to be exact if it satisfies the following condition. The partial derivative of m with respect to y is equal to the partial derivative of n with respect to x. And the method of solving it is basically integrating m with respect to x and then integrating n only for values of n which do not contain x. We integrate with respect to y, only values that do not contain x. Then the results in 1 and 2 are added and equated to a constant. That's how we solve. So let's take up an example of an exact differential equation and see how exactly we go about solving it. So given the following differential equation, how do we solve? So the question is example 1, 5x raised to power 4 plus 3x squared y squared minus 2xy cubed dx plus 2x cubed y minus 3x squared y squared minus 5y raised to power 4 dy is equal to 0. So this is our equation right here. So this will be our m, and this will obviously be our n. Now, before anything, we are going to first of all see if it's actually exact. So we are going to show that the partial derivative of m with respect to y is equal to the partial derivative of n with respect to x. Okay, let's get the partial derivative of m with respect to y. So differentiating this with respect to y, this will be 0. Differentiating this with respect to y, this will be 6x squared y minus, differentiating this with respect to y, this will be 6xy squared. And then getting partial derivative of n with respect to x, differentiating this with respect to x, this will be partially, this will be 6x squared y minus, differentiating partially with respect to x, this will be 6xy squared, and this will be 0. Now, is this and this the same? So look at this and this, they're actually equal. So it is exact and we can proceed to get the result. So in getting the result, as you can see, we integrate m with respect to x. So I want to take m and integrate it with respect to x. So what does that give? So that will be the integral of 5x raised to power 4 plus 3x squared y squared minus 2x y cubed dx. Integrating with respect to x, that will give us 5 over 5. So that will be x raised to power 5 plus 3 over 3. That will be x cubed y squared minus 2 over 2. That will be x squared y cubed. Okay, and then for the values of n, we are going to integrate with respect to y, but we are only taking values of n which do not contain x. Now look at n, which values do not contain x. So if you look at n here, this one has x, this one has s. So it's only the last bit that does not contain x. So we are going to take the values of n that do not contain x, and that is minus 5 y raised to power 4, and we're integrating with respect to y. And what will this give us? This will give us minus 5 over 5 y raised to power 5. Okay, so the answer is given by result 1 plus result 2 is equal to c. So result 1 plus result 2 is equal to c will give us, taking result 1, that is x raised to power 5 plus x cubed y squared minus x squared y cubed minus y raised to power 5 is equal to c. And this right here is our answer. Okay, fine. Let's take up another example. Let's say you're told to solve the differential equation. So example number 2, we have 2x cos y 2x cos y plus exponential x dx plus exponential y minus x squared sine y dy is equal to 0. So let's first of all start by identifying what our m and n is. So the equation is m dx plus n dy is equal to 0. So this is obviously our m and this is obviously our n. Now, is it exact? We are getting the partial derivatives. So get the partial derivative of m with respect to y and see if it is equal to the partial derivative of n with respect to x. Okay, what is partial derivative of m with respect to y? So differentiating this with respect to y, that will give us minus 2x sine y. With respect to y, that will be 0. And then now getting the partial derivative of n with respect to x, this will give, differentiating this with respect to x will give 0. Differentiating this with respect to x will give minus 2x sine y. Now, since they are equal, it is exact, and then we can go on into solving. Now, the procedure for solving, we take m and integrate it with respect to x. So integrate with respect to x, what will we have? So the integral of 2x cos y plus exponential x dx. Integrating the first term, that will be x squared cos y plus the integral of exponential x is exponential x. Then we take the values of n that do not contain x. So if you look at n here, this one has x, so it's only this that does not have x. And we integrate with respect to y, and that gives us exponential y. So our result is given by result 1 plus result 2 is equal to c. So that will be x squared cos y plus exponential x plus exponential y is equal to c. And that's our answer. So basically, that's how we go about solving exact differential equations.